Hello, my name is Michelle Tawada, and today I'm going to show you how to work with matrices in C++. But first, we need to define what is C++. Well, this can be defined as a language for object orientation programming. It's an extension of the language C. This code is considered an intermediate level because it uses high and low features for the code. It's one of the most popular languages used around the world. This because its main characteristic is that data types can be instantiated a lot of times, and it makes it also easier the declaration of user-defined classes, which helps implement a specific functionality to the program. But this program also includes operators like that are able to make arithmetic, comparisons, manipulations, and even logical operations. This is one of their most popular functions. It can perform addition, subtraction, division, and multiplication, which is the thing that we are going to use for this This video is about how matrix multiplication works in a code in the language C++. But before we start, I need to define what is a matrix. Well, matrices are these horrible things that are a rectangular array of numbers, symbols, or even algebraic expressions. All of these are arranged and focused in rows and columns. Matrices can be used to write in a compact way equations. This making work with them in a lot easier way, like to solve a linear equation or even a equation system. Well, without that defined, how do you multiply matrices? Well, it's a really tedious process, and it's really confusing at the first, but when you get it, it turns like a little bit easier. But for that, I'm going to show you a written example. So, in order to be able to multiply matrices, there are a few rules that must be followed. That it means, well, rows and columns must be represented by the letters m times n, where m is going to be the number of rows of the matrix and n the number of columns. So I'm going to give an example to explain how they multiply themselves. So we have matrix A multiplying matrix B. In order for this to be multiplied, there's a really important rule that means that the number of rows of the first matrix must be equal to the number of columns of the second matrix. So as you can see, in matrix A we have 2 rows, and in matrix B we have 2 columns, so this can be multiplied. So we will start by taking the first row of the matrix A and multiplying it by the first column of matrix B, and it will give you these numbers. And then we will do the same, but now with the second column. That will give us these numbers. And then we will do exactly the same, but with the second row. So we will take the second row and we'll multiply it by the first column of matrix B, and we will give you this. And then multiply it by the second column of matrix B, that will give you this. These numbers must reduce themselves, and it will give us 11, 0, 4, 0. And this is our last result. And as you can see, this is a comparison of the multiplication of the matrices in the calculator. As you can see, it's the same number as in the previous example. With matrices, you're also able to solve linear equations or even system of equations. But that's a process a little bit more difficult. It's not like this multiplication, and it also involves a matrix that is called the identity. But that's another story. So now for the interesting part. How do we perform multiplication of matrices in the language C++? So for this, I'm going to be using this web page that it's called reptile.it, and it's a really useful page because it allows you to not only work with C++ language, it also allows you to work with a lot of other languages. So I have pre-written my code, so I'm going to explain you how it works, and I'm going to give you also an example. So the first thing you need to do is to declare your variables. I suggest you to declare your variables on the top of your code. This in order for it to be like simple. If you get troubles with the code, you can find your variables in the top of the code, and you will not spend a lot of time searching for it. So the first variable that you will see, it's while, that it's a tool that will help you to create a menu. Why a menu? Because if you're working like not only with one type of operation, a menu will result much easier for you to work. Like for example, this menu says, this program will perform an array multiplication. So printf means that when you want the code to print a message after you click the button run, you must write printf, parentheses, open quotation marks, and also you must always put these little things, because if you don't put it, the code won't work. And believe me, it's a headache because I always forgot to put them, and it always marks me like error. So then scamp is the one that will tell the code that you are selecting something. Then we are going to use the switch option. This will help the code to divide in cases. That will help us to establish the menu. I will show you like how the cases are working. So in case 1, it asks you to enter the number of rows and columns of the first matrix and of the second matrix. And here's an important thing that I have told before. If you remember, I told you that a multiplication of matrix cannot be performed if the number of rows and columns of one matrix and the other are not the same. So here that's also established. So if you see here, it says if R2 equal C1. What does that mean? That it says that if row 2 is equal to column 1, the operation can be performed, so the code will run. Then it says, please enter the values of the first matrix, and it will ask you for the values of the first matrix. So it says that I, it's going to be the number of, I think it's rows, and J, it's columns. And if you see in scamp, it will help us to print the matrix forward. So it will say A, that it's matrix A, IG, that are the numbers that are going to, the values that are going to be assigned by you. And then the same with the second matrix. Then it will print the first matrix. Just this in order for you to see that you wrote the numbers you wanted to write and that everything is correct. And it will do the same with the second matrix. Then it will perform the operations. So here in this line, it says, like I told you, the code, it was established that A, IG is the first matrix, and B, IG is the second one. So here it basically says CIG, it's equal to AIK times KJ. Why this? Because if you remember what I told you, when you are performing a multiplication of matrix, you are multiplying the row by the column, then one by one, as I showed you in my previous example. So that's what K means. Like, it's a variable that helps you to storage data. And then it will print the result, that it's going to be the matrix C. Well, if you remember, the if was that if R1, it says R1 equals C1, that means that the the operation can be performed. But for example, if you write wrong those data that is really important, then the code will not be run. It will not allow you to run it. So it says that if you wrote it wrong, if you wrote that there are more columns than rows, then the operation will not be performed and it will ask you to enter your data again. Then break means that the first case is finished. And then the case 2, it says bye. It's really simple. It is that it is the second option here, is that when you already finished doing the multiplication of matrix and you want to exit the program, because the program will create a type of loop. So when you finish your multiplication, it will return you to the menu, and you will see it like an example. And then the default, that is you select this invalid option. So we suppose that instead of writing 1, you wrote 5. Well, then the code will tell you that it's wrong and it will run the menu again. So let's run the code and give an example, a series of examples for you to see that this works. Well, as you can see, here's the menu. It's asking you to select an option, and we will first select 1. So it is asking you for the number of rows and columns for the first matrix, and I'm going to write it wrong in order for you to see that if you write that there are more rows than columns in one matrix than in another, it will say that it's not possible to perform the operation. So here I'm going to write 3, 3, and the second I'm going to write 5, 5. So if you can see, here says matrix multiplication, it is not possible. Please try again. And then it says this program will await multiplication. Oh, here I have a little mistake. This is like an aesthetical mistake. I'm sorry. It's in order for you to see to look good. That's it. So, well, I'm going to type 1 again. I'm going to type 1 again. And this time I'm going to do it in the right way. So we're going to do a matrix of 3 by 3. So 3, 3, and 3, 3. So here is asking for the values of the first matrix. So I'm going to put like random numbers to... It's going to ask for 9 values. And then the ones from the second. Then, as you can see, it printed the matrices that look like this, and then the result. And I can show you the result in my calculator in a moment, so you can see that it's correct. So, what happens if you type an incorrect option, like I told you, for example, here, as I said, it's like a loop, so it returned me to the menu. So I'm going to type this time 5. And as you can see, it says, you have selected an invalid option. Please try again. This is what was seen in the default. And when you are finished, like doing this, you can type 2 and it will print bye. So you know that your program is over. So as you can see, here are the values that I entered in the code of the matrix that was 3 by 3. And this is the result that was given by the calculator, which is exactly the same that was given in the program. So the program works. This was my video for my project for the third partial of my 6th semester of high school. And I just want to thank you, teacher, for having us like a lot of patience and for teaching us how to program. It was really fun, and I think it's going to be really useful for me in the university. And I want to say that you are a really good teacher, and I'm going to miss you a lot. Thank you.